Good morning, one and all. Today, we are going to see the superposition theorem problem. So here, this problem seems to be somewhat more resistance are there. Seems to be somewhat difficult, but it is a very simple problem. If you see here, so here one resistance is there, here one resistance, here one resistance, again this. So while seeing the problem, you'll just think like it is a very difficult problem. It is very simple problem. So this is the circuit we need to solve. Here 4 amperes is there and 12 volts is there. Okay, so now we are considering only 4 amperes current sources alone acting. So next one more voltage source is there. That voltage source, what we are doing is we are short circuiting. So if you short circuit this particular this point, there will be not any current flow in this particular this part. Okay, so the current flow is 0. Okay, but just we are going to see how it is 0. Okay, hence it is short circuit. There will be not any current flow. So this current flow will be just 0. So they asked to find out the like current flow in 2 amperes, no, 2 ohms, no. So in this 2 ohms, if you short circuit, there will be not current flow throughout this particular part. So current flow directly you can tell like current flow through 2 ohms is 0. But so you just I am solving this how it is 0 to prove how this current flowing is 2 ohms is 0. Just what I am doing is I am redrawing this circuit like this. So I am marking this point as A. If this is A, this is also A, and this is this particular point is I am taking it as B. Okay, so this wire is connected here. This point also A, this point is C. So since it is short circuited, the current to 2 ohms, the current to 2 ohms is 0. So again, what I am doing is by marking the point, I am redrawing the circuit. So A and B, between A and B, you see between A and B. So 4 ohms is there. Again, here A and B, 6 ohms is there. So 4 ohms is there, and between A and B, 6 ohms is also there. Next, between A and A, between A and A, you see, where, yeah, between A and A, this A is there, this A is there. So between A and A, it is 2 ohms is there. So 2 ohms I am drawing. Next, I am marking this point as C. So between A and C, between A and C, you take between A and C, 6 ohms is there, and here also between A and C, 3 ohms is there. So 6 ohms is there, 3 ohms is there. And between A and C, again you see, between A and C, again 4 amps current sources acting in this particular direction, that is in this direction. So as it is, I am drawing this circuit. So, so there will be any current flow in this 2 ohm circuit because here it is open. Here it is open. That is since it is open, so there is no current to 2 ohms circuit. Okay, 2 ohms resistance. So the current to 2 ohms is 0. So here it is 2, not 2 amps. 2 ohms is 0. So current to 2 ohms is 0 amperes. Just to prove. Okay. Next, when 12 volts alone acting, when 12 volts now, 12 volts alone acting, now we are open circuiting the current source. We are open circuit this 4 amperes current source. Only we are considering only this 12 volts around acting. We are open circuit this current source. So I am again redrawing this circuit like this. Again redrawing the circuit like this, that is 12 volts is acting here, and this 4 amperes is open, and again I'm redrawing the circuit. Now what I'm doing is I'm marking this point as A, this point is A. Okay, next we need to find out the current flow through this 2 ohms resistor. So we should not disturb this 2 ohm resistor. So we need to make this intact. This is A. This is this point we are making as B. Okay. This point we are taking as D like that. This point as it is we are taking as C. Okay. This D you just okay, cut off. Here this is D. This is C. Now what we are doing is this 12 volt as it is we are taking, and here you see this 10 amperes. So how it is 10 amperes across this 12 volts. This 6 and 4 ohms are in series. So 6 plus 4 is 10 amperes. So this I am as it is I am taking. That is across the A and D point. So this next next this 6 and 3 again A and across this A and D point, 6 and 3 again is this two are in series. So I'm 6 plus 3 is 9. So I'm taking 9 ohms here. Okay, like this it is connected. Okay, it is connected in parallel like this. Next, again, now we need to find out the current through this 2 ohms. So just like that, I am taking like this. Okay, this is connected like this. So say same. This is the A point. This is the D point. So between A and D point, again 2 ohms is connected like this. So we, as I said before, this current flow to 2 amperes only we need to find out. So you just make this as intact. Don't disturb this current flow to 2 ohms. Now, what I'm doing is I'm taking this 9 ohms this side. Okay, 9 ohm because this 9 ohms and 10 ohms are connected in parallel. So 9 ohms you can, because this two wires, no, just what we are doing is we are taking this wire and connecting like this. Okay, this also 9 ohms we are taking this wire and connecting like this. So 9 ohms and 10 ohms again in is in parallel. Okay, so this 9 and 10 ohms again in parallel, na, just we have to okay, simplify this and find out the equivalent resistance between this 9 ohms and 10 ohms. So 9 into 10 divided by 9, 9 plus 10. So if you simplify this, you will get 4.736 ohms. So that I am taking over here. So now what we need to find out is current flow through this 2 ohm resistor. So the current flow through this 2 ohm resistor is I is equal to V by R. So V is 12 ohms divided by this 2 ohms. So that is 6 amperes. So the current flow to 2 ohms, that is I double dash is 6 amperes. So that is by using the this voltage is 12 volts, and by using the current source 4 amperes, this the current flow to 2 ohms is 0. So now I total we need to calculate. So I total current flowing 2 ohm resistor is I total is equal to I 2 ohms dash plus I 2 ohm double dash. That is I total 2 ohms equal to I 2 ohm dash is 0 amperes plus I 2 ohm double dash is 6. So 0 plus 6 is 6 amperes. So current to 2 ohm resistor is 6 amperes by using this superposition theorem. By using the superposition theorem, this is the answer for this particular circuit shown in